Hi, today we're going to take a look at something called continuous compound interest. Continuous compound interest is something very similar to what we may have done with exponential growth and decay with that formula y equals a 1 plus r to the t power. We had exponential decay where instead of a plus we had a minus sign there. And then we changed this, we altered this formula a little bit for compound interest, dividing by an n, multiplying n, and that n was how many times something got multiplied or broken down into a year. The difference now is continuous means instead of doing something 4 times a year, twice a year, at the end of each year annually, this thing just keeps rolling over and keeps gaining interest. So we gain interest, and then with that, we gain more right away. So it's constantly rolling over. So we are going to amend this and use this new formula. So like what we originally had, A is going to be our final amount. P is something called principal. So that's kind of our same thing as saying our starting amount. E ends up being a number. More on that in a second. R is rate. T is time. E. E is a number. E is a number the same way as pi is a number. Pi, this fancy number, 3.14. It goes on and on and on and on and on. What's so special about pi is it never stops, it never repeats. We call that an irrational number. E is something in the same family. It also is an irrational number and has this value of 2.718 something, something, something. Who cares? All that matters is this decimal never stops and it never ends. It's also an irrational. Pi and E, they're cousins to each other, so to speak. Now, we know what we have. We need to find all this information within here. So let's take a look at the problem. John invested $3,000 into a college savings account that pays 4% interest compounded continuously. There's no more money getting put in or taken out. What's the balance after 10 years? So we need to know how much we start with, what's our rate, what's our time frame. Let's take those three numbers and drop them into this. So we're finding some number. We know we start with 3,000. We multiply by an E. We're talking about 4%. We need to take that 4% as a decimal, as 0.04, and our time of 10 years. Now it's a matter of just order of operations and just algebra, simplifying this. So start with our exponents, multiply these two things together. We get 3,000 times e to the 0.4 power. On our calculators, you may find an e button. You're going to push that, raise it to an exponent of 0.4, and we're left with 1.49. Multiply that by 3,000, and we end up with 4,475. So after 10 years, starting with $3,000, we get $4,475. Now, what if I know how much I want to end with? I want to end this time with $10,000, and I want to figure this out for after 18 years. How much are we going to start with? Okay, so let's take that same formula. Instead of putting 3,000 in the start, we're putting 10,000 in our final. We don't know what our start is. E is a number. Our rate is still 4%, 0.04, and this time we're talking about 18 years. Okay, so order of operations again. Start with our exponents here. Let's multiply them together. 0.4 and 18 is going to give us 0.72. So we have e to the 0.72 power. If you find the E button, raise it to 0.72, we end up with 2.05 times P equals 10,000. Now, P times this, we have multiplication. Let's divide. Let's divide. They cancel. My P, how much I'm starting with, I need to invest initially $4,878. So we can do this both ways, whether or not we're putting money in or finding how much we want at the end. and that is continuous compound interest.